What's going on, guys? Today we're going to talk about important web components. Important web components is part of a TryHackMe challenge or a TryHackMe room. You can take a look at the room here. Room name is Putting It All Together and explains important web components. Now, before attempting this room, I would advise you guys to visit the room that is about how the web works. There is a walkthrough I published. You can see the video on the screen. Click on it, watch the video, and then come back and watch this video right now. Okay, so let's talk about important web components. These web components are all play important parts when you access websites on the internet. So basically, let's first talk about the first component. So I'm gonna start with DNS server. Okay, start from here. So the DNS server is the party which actually receives the request and translates your request from a website into an IP address. So basically, if you request Facebook, .com, your DNS server will translate or will convert the domain to its own IP address, the corresponding IP address, so that you will be able to access the website. Okay, that's the role of a DNS server. Now, there are many types of DNS servers. We have the local DNS server, and we have the authoritative DNS server. We have the root DNS servers. Now, root DNS servers have wider databases about websites and their IP addresses. If you have local DNS server configured on your machine and say that you requested facebook.com, but your local DNS server didn't have the corresponding IP address, then it will ask the authoritative DNS server, and if that also doesn't know, it will forward the request to the root DNS server. That's how the DNS server works in brief. Now let's talk about databases. So that's the first component. The next component is database. So databases hold information. That's it. So whether they are, we have multiple sorts of databases. We have SQL database, we have NoSQL, we have Oracle. No, Oracle is a software actually. SQL, NoSQL, PostgreSQL. These are all databases or type of databases. So basically, databases hold information that are necessary for the render of your website. So databases usually are working behind the scenes, meaning in the backend. So you don't see how the web server is accessing the information you requested. It's all happening in the backend. That is for databases, just to know that they hold information. And there are two types of databases. You have the relational, okay, and you have the non-relational. So basically, the relational databases are the types of databases that store information in rows and columns. Example is SQL database. Non-relational databases, they don't store information in rows and columns. And example of non-relational are NoSQL. NoSQL is one of them. Alright, so now let's talk about, we talked about databases, we talked about DNS servers. Let's now, guys, talk about web servers. So that will be the third component. So I guess, guys, you know what does web server mean or how web server works. Web server is software that listens for incoming connections. Normally, web servers listens on port 80 or port 443, depending on your SSL certificate settings. So it listens for incoming connections, and then it utilizes the what's called the HTTP protocol. Okay, so it uses the HTTP protocol to communicate with what? With the browser. So here we have the HTTP protocol between you as, let's say, browser. You have the browser and the web server. So normally they communicate through HTTP methods. So we have the get method. Get means you are asking to retrieve a web page from the web server. Yeah, post. Post is posting information or on the web server. We have head, and we have several other methods, but most commonly we have the get and post. So that's how the web server communicate with the browser, through HTTP protocol and HTTP methods. Listens on incoming connections on port 80 or port 3, and there are many kinds of web servers softwares. One of them is, or the most popular is, Apache, also Nginx, and for Windows we have Internet Information Servers. So that's for the web server. It's the piece of software that is receiving your request through the browser, and when the web server receives the request, it will ask the database for information. As I told you guys, databases hold information. So when the web server asks the database for information, the information comes back and the page is rendered. Sometimes the web server doesn't ask the database, it just has the information in its root directory. So basically the web server has root directory. The root directory is where it stores information, such as, for example, in Apache the root directory is /var/www/html. The same in Nginx. But in IIS the root directory is kind of different. It lies under C initpub. Okay, and then www root. Now under these directories, okay, the information are stored. For example, let's say you requested to access an image, say fb.com/ say index, a web page in PHP. Now the web server will retrieve the web page from its root directory, either in Windows under www or under HTML in the case of Apache or Nginx. That's how the page is requested and retrieved. Now in case there was a need for using the database, for example, let's say there was parameters here, index.php and p equal, say 1, parameter equal 1. In this case you're using parameters to access different content on the page. So basically it uses the database. In this case it asks the database about the contents that is corresponding to a key equal to 1. Okay, so that's how web server, DNS server and databases work. Now let's talk about other components. Other components can be such as, first, the web application firewall, or WAF. Now application firewalls, guys, they sit between the request, okay, and the web server. Let's take an example, see if you have a place here on the board. So say here is Chrome browser, okay, and let's use another color like that. Okay, so Chrome, and here you have web server. Okay, the WAF sits in the middle. Its job is to protect the web server from common cybersecurity attacks or denial of service attacks. So there are many techniques which WAF employs to actually protect the web server from common web application attacks or denial of service attacks. One of them is the rate limits. So basically WAF protects web server from denial of service attacks by using something called the rate limits. Rate limits means that the web application firewall allows certain number of requests per IP address. Say the Google Chrome or you has an IP address of 1111, right? The application firewall allows you to send, say 10 requests per second. All right, that's how it makes sure that you do not overflow or send an excessive amount of traffic to the web server that it cannot handle it. So the WAF allows you to send, let's say, 10 requests per second. If you send more than 10 requests per second, it will block your IP address. It will drop the packets. Sometimes it doesn't block the IP, it just drops the packets. Alright, that's for application firewall. Now let's talk about CDNs. Now CDNs is a term used very often in the world of search engine optimizations. So basically, if you work in SEO, you may have heard that one of the best practices to speed up a website is to use a CDN. CDN stands for Content Delivery Network. And CDN is actually a network of servers around the world. These servers, they store static information on their end. So basically, say I have my site fb.com, alright, and if I want to speed up the loading time of my site, I would ask the CDN, or I would store the static files on my website, such as CSS, GS, HTML, images. All sorts of static content can be stored on the CDN, okay, on the edge servers. So what happens, guys? Let's say a user located in, let's say we have a user in China, okay, and a user in US. Now they requested fb.com both, okay, and you owning the domain, you are using Content Delivery Network to store static files to speed up your website. So what happens, your website or your content now is stored across many different servers around the world. Some of them could be in China, some of them could be in the USA. Now a user in China has requested to access your site, and given that you're using a CDN, the request doesn't go to your site, it goes to the server that is close in proximity in China, okay, to respond to the person's request. In other words, if you are in China and you requested fb.com, your request will be rendered by a server located close to China geographically. Same here. A user in the USA has requested to access fb.com. fb.com is using a CDN. The CDN will handle the request and it will send the response, right, from a server located in close proximity to the USA. It could be in the USA as well. That's how that's how the traffic doesn't travel from USA to the server location that is storing fb.com. Say your server is located in I don't know, Qatar, okay, so there's actually many routes and hubs between USA and Qatar. So a user requesting the website from USA will have the request rendered much faster when they receive the response from a server located in the USA, not in Qatar. That's how CDN works, and that's how it speeds up your site. Okay, now lastly is the load balancers. So the load balancers, let's talk about load balancers in a new page. So say this is the load balancer, okay, and this is a client browser, a computer, let's say Chrome, and here we have server 1, server 2, server 3, okay, and all of these servers, they render one website. It is fb.com. Okay, so in load balancer, guy, when an environment is using load balancers, what happens when you send a request to access fb.com? What happens, the load balancer will send your request to one of these servers. Okay, there will be multiple servers to respond to your request, but the load balancer will send the request to the server that is at the least busy. Okay, the server that is consuming the least amount of resources. Why? Because this way your request will be rendered fast. So say the server is occupied 80%, say this one is occupied 60%, say this one is occupied 30%. Alright, what happens, the load balancer here, this is the load balancer, will probe the servers and see which one has the least usage. So it detects that server 3 is using only 30% of its capacity, okay, in terms of CPU power, in terms of traffic, in terms of RAM. So what happens, it will send the request now to this one. Since server 3 is actually not busy, it will process your request faster and send you back the web page. Alright, that is how load balancer works. It actually distributes the weight across many servers. Now sometimes you have multiple requests coming and there is no chance to lay all of these requests to one server. In this case, the load balancer will distribute the request to all the servers. So all the servers will simultaneously work on your request. Additionally, guys, when one of these servers goes down, say server 1, server 3 is down, server 2 is down, what happens, the load balancer will send a request to the server that is up, means it's server 1. That's how load balancers work. Now load balancers perform periodic checks with each server to ensure they are running correctly. This is called the health check. So the health check, through which the load balancer will determine which server is up, which server is down. If a server doesn't respond appropriately or doesn't respond, the load balancer will stop sending traffic until it responds appropriately. That's how we call it load balancers. Alright guys, these are the web components. Now let's take a small challenge from TryHackMe to put all of this together. So if you click on view site, here we have to sort all of the components in the right order. So what happens here in the contents, we have a user requesting tryhackme.com. We have to go through all of the steps, okay, that are usually followed in the internet arena, so that you drag all of the steps in the correct order. So the first thing, as you can see, we have the request tryhackme.com in your browser. What happens when you request a domain? Here comes the role of the DNS server. So basically we will ask the DNS server about the IP address of tryhackme.com, as I explained. So the first step will be check your recursive DNS server for address. Oops, not right. As you can see, when it's not right, we have a red on the edge. The edges turn to red, so we have to drag this back. Not this one, it's one of the DNS server. Query root DNS server, nope. Oh yeah, it's one. So basically we check local cache for IP address. So the local cache meaning we ask the ARP table. By using the command ARP-A, we display the contents of the ARP table. If a match is found for the domain tryhackme.com, you will be given access to the website, or the process will go forward. If there is no match in the table, on the ARP table, it means that the local DNS server doesn't have the IP address for tryhackme.com, which we are requesting. So what's going to happen, we will ask for the recursive DNS server. Okay, if this doesn't know the answer as well, we will ask the root server to find authoritative, or to find the answer or the IP address for the website. Now usually if the IP is not found with the local cache or with the recursive DNS server, it will definitely be found with the root server. So by reaching this step, okay, you will have access to the IP address, or your DNS server or your browser will be able to determine the IP address of TryHackMe.com. Now you'll be able to connect to the web server or the website. So the next step coming, we have either the load balancer or we have the application firewall. The application firewall sits before the load balancer, so this is the next step. No? Yeah, we forgot this one. So this one here. Authoritative DNS server advises the IP address for the website. And next, we request, as you can see, after we determine the IP address, we start communicating with the other end. Now the other end is the web server, but the web server uses firewall. So the request first has to go through the firewall. Request passes through application firewall. If all is good, the request now is passed to the load balancer. Now, as we talked about, as we mentioned earlier, load balancers distribute the weight across many servers. So the next step is we connect to the web server. So here, connect to web server on port 80 or port 443. After we connect to the web server, it's time now to receive the page. So web server receives the GET request, okay, and then web server talks to the database, and lastly your browser renders the HTML into a viewable website. Here you get this flag for this room. So that's how it works, guys. I hope you enjoyed the video, and I will see you later.